Sketch exercise number 2, solution, the footing exercise. I start by writing my name and my section, and the problem is one of spreading out the loads, this load coming up here, such that it doesn't overwhelm the bearing capacity of the soil. So we start with the force here of 32,000 pounds, or 32 kips. 32 kips is a nicer number, so I'm going to say that. The maximum bearing capacity of the soil is 2,000 pounds per square feet. I'm going to convert that to 2 kips per square foot. I'm going to write it like this, just so I can keep track of what's going on. So the units, as usual, give me a clue as to what I need to do. I need to determine the area necessary to spread out the 32 kips so much that it doesn't overwhelm the soil that is capable of supporting 2 kips per square foot. So, as we saw in lecture and in Qing, the area is equal to, the area in square feet is equal to the load of, let's call it P, of kips, divided by the bearing capacity of the soil. Let's call it C, in kips per square foot. And so, given that formula, we enter our real numbers. 32 kips divided by 2 kips per square foot equals how many square feet? 32 divided by 2 is 16. And the units, kips divided by kips, goes away, is 16 square feet. A 4 foot by 4 foot footing. 1 foot at a scale of 3/4 of an inch equals a foot. I mean a 16 square foot column. That's 4. I can either count the dots. I can do that. So a 4 foot by 4 foot footing looks something like this in plan. In section, I'm told that the footing needs to be 1 foot deep. Footing in section looks something like that. So since this is cutting through the footing, I'm going to use my heaviest line weight to show that footing. Show the approximate location of steel reinforcing bars as dotted lines. Well, I know, because I read the book, that we need to keep the reinforcing bar at least 3 inches away from the soil. And since each of these dots is 1/3 of a foot, that's equal to 4 inches, so 3 inches is somewhere in there. So I know all my steel needs to be at least 3 inches away from the soil. I also know that because the footing is going to want to flex up under these loads, as shown in the lecture, that the steel needs to be at least 6 inches below the top. It needs to be in the bottom half. So that gives us a zone in section for the steel reinforcing bar that is in here. The way Qing likes to draw that is like this. And so I'm going to draw that, and I'm going to keep the bars there. I'm going to show the bars running the other way, like this. And I'm just going to have a reasonable spacing. And again, in plan, if I want to keep the steel at least 3 inches away from the edge to protect it from moisture coming in through the concrete, which I know is porous, then I'm going to keep the steel inside that. So I can draw it at 4 inches. So there's the outer bars of steel, and they will cross. So the grid of dots helps me quickly and with some degree of precision locate my steel. What is the right spacing for the steel? 2 inches is too close, a foot is too far apart, so somewhere in between 2 inches and a foot is the right spacing. In the Boston area, I remember it was mentioned in lecture, the frost line is historically about 30 inches below the surface of the ground. I also recall from the reading and the lecture that the footing needs to be at least 12 inches below the frost line. So the bottom of the footing is 12 inches below the frost line, so this must be the frost line. And if the frost line is 30 inches, that's 1 foot, 2 foot, and a half. So there's my ground level line. And so it says show and dimension, so I'm going to give a dimension for that depth. Draw a dimension line. I'm going to say 42 inches, or I could say 3 foot 6 inches. Looking it over, I see that the assignment calls for drawing the footing in plan and section and showing its dimensions. So I make sure that my line weights, the line weight of the outline of the footing should be darker than the dashed lines of the steel. I show my dimensions, dimension lines. That's 4 what? 4 feet. Here as well. Dimension lines, 4 feet. The section as well, it is 1 foot deep as given. You could also dimension the width of the section. That works. So the points assigned to this, first of all, if you did the math right, 32 divided by 2 equals 16. 16 square feet is gives you a 4 by 4. If you got the numbers right, that's 1 point. If you got the units right, that's another point. If you provide dimensions in the plan and section, that's a point. If you indicate the ground line and dimension it to the bottom of the footing, that's another 2 points. It helps to indicate the frost line. If you, in section, if your steel falls within that zone, at least 3 inches away from every surface, and in the bottom half, at least 6 inches away from the top of the footing, if your steel is drawn within this zone of steel in section, then you get another point. If your steel is drawn in plan, within this acceptable steel zone, which is at least 3 inches away from the edge, you get a point for that. If you drew everything more or less to scale, and if your you get a point. And if your graphic quality is reasonable, you get another point. That adds up to 10 points. And that's it. Thank you very much.